Hello everyone. This is supposed to be a quick rundown of the algebra portion of the semester test that we'll be taking. I'm going to go through it pretty quick because this is just supposed to be a supplemental resource. If you have questions about any of the ones, like any specific steps I do, it's your responsibility to come in and see me. So here we go. The first question is on factoring. There's only two items, so you're going to be doing greatest common factor factoring. There's no number they have in common because there's a 1 in front of the a squared. So the greatest number I can divide out of 1 and -10 is just 1. But if I look at the a's, I have something in common. They both have an a, so I'm going to divide an a out. When I divide an a out, I'm left with a out front. What's left behind? There's a single a, -10. The second one doesn't have any a's left behind, so that is why it's D. Question number 2. This one involves actually factoring. So I can't divide a 2 out of everything, so I think to myself, the only way that this could be a 2x squared out front would be if these first two terms was a 2x and an x, and the only way that this is going to be a -40 at the end would be if these two numbers multiply to make -40, and they also need to combine to make +11 in the middle. So I'll show an example of one that doesn't work, and then we'll note the one that does. I might think to myself, what two numbers multiply to make -40? Maybe it's something like, I don't know, -20 and 2. That multiplies to make -40, but if I actually double distribution this whole thing out, I would get 2x times -20 is -40 plus 2x in the middle is -38, and that's nowhere near the 11x's that we need in the middle. So I play with all the combinations, and I eventually will find that the correct one is -5 and +8. Let's check by multiplying it all out. 2x times x is 2x squared. 2x times +8, 16x. Now the -5 distributes, -5x. And I end up with 2x squared plus 11x minus 40. It creates what I want. So that's why it's A. Question 3. The goal here is to solve. Our tools in this section are things like square roots, factoring, complete the square and the quadratic formula. There is no x, so then there's no x. That means nothing will get stuck. So I'm going to solve by taking a square root. My first goal is to get x squared all by itself. So I'm going to subtract 6 from both sides. I'm then left with 5x squared equals 5. Divide both sides by 5. You need to get x squared by itself. I get 1. Then I take the square root, and when I am taking the square root to solve, I'm going to get two answers. There are two answers because the biggest power in my original equation was a 2. My two answers are plus and -1. That's why it is C. Question 4, similar idea. There's no single x hanging around, so my first goal is to get the x, or the x -1 squared, the item being squared all by itself. So subtract 4, and I'll be left then with 63. And then some people try to take a square root here. You can't. You're going to get that 7 will be stuck. You'll have a square root of 7 still in there. So divide both sides by 7. Get the item being squared all by itself. I'll be left with x -1 squared equals 9. Then I take a square root to undo the square. And when I take the square root of 9, I get two answers. It's either that x -1 is a -3 or x -1 is a +3. If I add 1 to solve on the left side, I get -2. Add 1 over here, I get 4. My two answers, +4, -2. Question 5. I'm going to put parentheses around this just to kind of make it more clear. I have two items being multiplied by each other, making 0. If I use colors, I've got red thing times green thing equals 0. One of them has to be 0. If it was the red thing, it would have to be that m equals 0. If it was the green thing, it would have to be that m equals -7. So that's why it is B. Number 6. You need one side equal to 0 when you're solving for quadratics. I can't use square roots because this n would get stuck. So I need one side equal to 0. Let's add the n over the other side. So I have 2n squared plus, if I add n to each side, I'll have 3n's minus 5 equals 0. Can't use square roots. I'm going to try factoring. If you don't want to try factoring, you can use the quadratic formula. If you're using the quadratic formula, a would equal 1, b would equal 3, c would equal -5. So I'm going to factor it if I can, because I don't want to have to go through all the steps of the quadratic formula if I can avoid it. I know the beginning's 2n squared, so it has to be 2n and n. The last term is minus 5, so it has to be, a negative 5 and a positive 1, or a positive 5 and a negative 1 somewhere. The correct combination is going to be, let me see here. I need a negative 5, so let's go with, see if this will do it. I'll end up then getting, nope, that's not it, because this will make negative 3n in the middle, so I need the opposite. So I'm going to need, that'll do it, because then I'll have 2n times n is n squared. 2n times minus 2, or minus 1 is minus 2n, times the 5, or plus the 5n in the middle. That'll make 3n. So there's the factoring. Now, in order to solve, I know this thing could be 0. That would be n equals 1. I know this thing could be 0 by doing 2n plus 5 equals 0. Subtract 5. Divide by 2. 5 divided by 2 is negative 2.5. And that's why it's A. In 7, identify the vertex of the graph of this function. We had learned that the vertex's x-coordinate is always going to be located at negative b divided by 2a. We derived that in one lesson. So if you want to go back and see it, the derivation is in the note packet. You can find what section it corresponds to by looking at your review sheet. Otherwise, I'm just going to use this result. So a is equal to negative 4. It's the coefficient out front, the leading coefficient. B is equal to 2. C is equal to negative 1. I don't need C to find the vertex's x-coordinate. C is actually the y-intercept. So I substitute in negative of a 2 over 2 times negative 4. That leaves me with negative 2 over negative 8. That leaves me with 0.25. That's the vertex's x-coordinate. And if I look, I'm now down to two options. It is either A or it is D. It is not C or B, because both of these have a vertex x-coordinate is equal to 0.25. How do I find the y-coordinate? I'm going to take 0.25 and I substitute it in for x in my equation. So my vertex's y-coordinate is negative 4 times 0.25 squared plus 2 times 0.25 minus 1. And when I run that, I'm going to find it's negative 3/4. We did this by storing the value in the calculator. So 7 is A. 8, state the number of x-intercepts for the graph. The number of x-intercepts was based on the discriminant of the quadratic formula. The quadratic formula says that if you want to know when y is equal to 0, you use the following formula. It's negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You derived that. You actually derived it and wrote it down on a piece of paper, the majority of you. The important part about this in terms of the number of x-intercepts is this value. If that value is positive, you can take the square roots of positive numbers. So if I call this d for discriminant, if d is greater than 0, we are going to have 2 x-intercepts. Because I can take the square root of positive numbers, I get 2 answers. If that discriminant is equal to 0, well, the square root of 0 is just 0, and I only get 1 x-intercept. There's no such thing as plus or minus. If that discriminant is negative, I cannot take the square root of negative numbers, so I get 0 x-intercepts. So I need to find what this one is. In our case, it will be, so A is equal to negative 4, B is equal to 2, C is equal to negative 1. B squared minus 4ac. So that would be 2 squared minus 4 times negative 4 times negative 1. That's 4. This is a negative, a negative, and negative. That's 3 negatives. That means the overall thing is going to be a subtract still. 4 times 4 is 16. 4 minus 16 is negative 12. I cannot take the square root of a negative, so it is this case. That's why it is no solutions. There's no x-intercepts. Question 9 and 10 are just identifying some of the functions we've studied all year. This is a line. That is y equals mx plus b. That you just need to recognize. 10. This is an exponential. The reason it's exponential is because I start at negative 2 and I multiply by 1.2. And my variable is in the exponent. If I repeatedly multiply by 1.2, that makes exponents. So that's why we call it exponential. Is it growth or decay? Well, you're repeatedly multiplying by 1.2. If you multiply by a number bigger than 1, you're going to get larger. So that's going to be exponential growth. it'll be growing in a negative sense. This actual graph starts at -2, and it grows this direction. It's still growing, it's just growing negatively. So this is more of a curve, it looks like that. 11, simplifying with square roots. When you're simplifying with square roots, you want to divide out as many perfect squares as you can. So in this case, I can break the square root of 20 because it's the square root of 4 and the square root of 5. U cubed is the square root of u squared and the square root of u. V to the 5th is square root of v squared, square root v squared, and square root of v when I break them all down to their perfect squares. Now I'm going to pull out all the perfect squares that I can. Square root of 4 is 2. The square root of u squared is u. The next one, there's a v, and then there's another v, so that's going to be v squared. What's still left in the square root? Well, so we'll cross these out, use this, use this, use these. There's a 5, a u, and a v. So a 5, a u, and a v. And that is why it is a. 12, solve each. Remember to check for extraneous solutions. So this is kind of the opposite of what we did earlier. I'm solving for a square root. So my first goal is to get the square root by itself and then use squaring. So subtract 1 from each side. I then get 8 is equal to square root of b minus 3. Then square both sides. 8 squared is 64 equals b minus 3. Add 3 to the other side, and I get 67. If you plug 67 back in, you will see that it works. So it's D. 13 is a review of some trig ratios that we did. This is looking from angle x. It asks us to find the cosine ratio. So I'm using SO, CA, TOA. That's the acronym that helps me remember which sides I'm comparing for each trig ratio. The cosine ratio compares the adjacent divided by the hypotenuse. The adjacent side, so let's label all these. 35 is the longest, that has to be the hypotenuse. The 21 is directly opposite, which makes 28 the adjacent. Cosine is adjacent over hypotenuse. The adjacent is 28, the hypotenuse is 35. So I have 28 divided by 35. Those are both divisible by 7. So if you simplify, you're going to get 4 over 5. 14, you're going to be using a trig ratio then to solve for missing sides. So here I'm looking from an angle of 44 degrees. If I look from 44 degrees, I'm after the opposite, and I have the hypotenuse. That's the sine ratio. So that means the sine from my 44 degree angle is equal to x divided by 18, my opposite over my hypotenuse. I solve by multiplying both sides by 18. And when I type this in my calculator, I'm going to get 12.5. If I type in 18 times sine of 44. 15, here is we're going to be using an inverse trig function because I don't know the angle. So if I call this angle A, I have the adjacent, and I have the adjacent and the hypotenuse. So I know then that's the cosine ratio. So the cosine from angle A is equal to the adjacent, which is 53, divided by the hypotenuse, which is 58. I don't know the angle, so I have to use the inverse. So the inverse takes the ratio of the sides as the input and outputs the angle. If I type that in a calculator, you're going to find that it's 24 degrees. Make sure your calculator is set to degrees. So if you go to mode, make sure that it's set to degrees there. 16, finding the vertical and horizontal asymptotes. The vertical asymptote occurs at the x value that you cannot pick. I cannot pick -2 because that would be making the function divide by 0. So my vertical asymptote is going to occur at x equals -2. If I were sketching this graph, I'm going to have a vertical dashed line at -2 to remind me I cannot pick that. My horizontal asymptote occurs at this vertical shift. Y is never going to equal exactly -3 because this piece right here is never going to equal exactly 0. Since this piece won't be 0, I'm never going to get exactly to -3. So I should have a horizontal asymptote at -3. So this is at -2. This is at -3. Let's do some colors. And then the rest of the graph would look, something like so. But this is just asking about the asymptote, so that's why it is A. Simplifying with, we call these rational functions. They're a ratio of polynomials. How do we simplify it? Well, just like in simplifying fractions in middle school, you have to factor first. So I factor the top. I need two numbers that multiply to make 49, add up to make -14. That's going to be minus 7 and minus 7. Down below, I need two numbers that multiply to make negative 49 add up to be 0 in the middle. That's a difference of squares. That's m plus 7 and minus 7. If I look, these m minus 7s will simplify out. So the only thing left is m minus 7 or over m plus 7. And that's only one option, so it's A. The excluded values are the values that I cannot put in the original function, and that would be negative 7 and positive 7 because it would make divide by 0. Same idea here. Simplifying, state the excluded values. So factor the top. If I factor the top, I'm going to get minus 10 and plus 9. If I factor the bottom, it looks to me like I'm going to get, what is that, minus 10 and minus 2. If I look, these will simplify out, so I'm left with x plus 9 over x minus 2. That is A. The excluded values are positive 10 and positive 2 because that would make the bottom be 0. 19, if I want to divide fractions, I multiply by the reciprocal. So 2 over n plus 7 multiplying by the reciprocal, n squared plus n minus 42 all over n minus 6. I'm going to factor the top so to see if I can simplify any fractions or anything in the statement. That's going to end up being, what, n plus 7 over n minus 6. Hey, I'll notice these simplify out, so I'm left with a 2 n plus 7 when I multiply across over n plus 7. These also simplify, so I'm left with just the number 2. 20. How do I add fractions? I need a common denominator. So to make a common denominator, my common denominator is going to have to be n minus 1 and n minus 5. So I need that on each side. That's what each one is missing the other one. So that means on the left side I need to multiply by n minus 5 on top and bottom. Over here on the right side I need to multiply by n minus 1 on top and bottom. Then I multiply out, so I get 2n minus 10 plus, over here this will be a 4n squared minus 4n all over my n minus 1, n minus 5. Now I combine my like terms up top. When I combine my like terms, I'm going to get 4n squareds. 2n minus 4n is negative 2n minus 10, which is exactly what they have in A. So once you simplify it, you're going to be left with that one. 21, find the population standard deviation for the data set. And then in 22, it's find the mean. To do this, you need to have your calculator. You go to Stat, Edit. You enter your data into L1. This is an old data set I had. If there's data in there, you hit Clear, Enter. So you enter your data set. I'm just going to make up numbers. These aren't the ones you'd actually type in. You enter your data set, then you go to Stat, over to Calculate, choose one variable statistics, hit Calculate. It will give you your mean right there. It will give you your standard deviation right there. These are not the actual answers for this one because you need to type in the real data. But there's your mean, there's your standard deviation. When you do that for questions 21 and 22, the standard deviation for this one is 2.98, so that's why it's D. The mean for this one is 8.4. 23. This one says selecting which 7 players will be in the batting order on a 12-person team. They didn't say that the batting order was important, just being in the batting order is important. So this is a combination. So it's from 12, you need to pick 7. And when you type that in your calculator, you're going to get 792. 23 says there are 40 applicants for 3 jobs, computer programmer, software tester, and manager. Since order is important because each person has a different position, we're doing a permutation. From 40, we are selecting 3. When you type that in a calculator, you're going to get C. 25, find the missing side of each triangle. This is a Pythagorean theorem question. X squared plus 3 squared equals 5 squared. That's going to be x squared plus 9 equals 25. Subtract 9, you get 16. Take a square root, you get plus or minus 4, but it can't be the negative, so it's just got to be positive 4 since we're talking about distances. 26, find the area of each triangle. In order to find the area of a triangle, you need to do 1/2 base times height. So in this case, area equals 1/2 base times the height. these are going to be, well, let me see here actually. Oh, so I need to find the height, so I have to do Pythagorean theorem here. So I've got h. So I know h squared plus 10.8 squared equals 12 squared. That would be h squared equals 12 squared is 144 minus 10.8 squared is 27.36. If I take the square root of that, I'll find the height is equal to 5.23, which then means if I want to find the area of the entire triangle, area is 1/2. The entire base is 10.8, but there's two of them. So what's that going to be? 21.6. The height is 5.23. If you type that in a calculator, you get D. 27. There are 11 shirts in your closet, 3 blue, 3 green, 5 red. You randomly pick one. What's the probability it's blue or green? Blue or means add, green. I can't be both, so these are mutually exclusive. They can't both be blue and green. How many are blue in there? They said there were 3 out of 11. How many are green in there? 3 out of 11. If you add those together, you get 6 out of 11. 28. A basket contains 6 apples and 4 peaches. 5 of the apples and 1 of the peaches are rotten. You randomly pick a piece of each fruit. What is the probability it is fresh or it is a peach? These are not mutually exclusive because you could be both. So the probability that it is fresh plus the probability that it is a peach minus the probability that it is fresh and a peach. Well, what's the probability that it's fresh? One of the fruit is fresh. So let's, if I draw a picture, 6 apples, 4 peaches. 5 of the apples and 1 of the peaches are rotten. So apples, we've got good and bad. So 1 is good, 5 are bad. For the peaches, 1 is rotten for the peach, so bad. And how many goods? 3. Probability that it's fresh or good, well, that would be 4 out of 6, so 10. Plus the probability that it's a peach. Peach is 4 out of 10. Minus the probability that it's fresh and a peach, which is good and a peach. Well, that's 3 out of 10. If I add that together, I'm going to get 5 out of 10, which is 1/2, which is why you're getting not mutually exclusive. So there you go. That is it. If you have specific questions, come in and see me, but hopefully this helps a little bit.